molality. It's not really that much different than what does it sound like? Molarity. It's not much different. Here's the formula for it. Molality is moles of solute per kilogram of solvent. Not a whole heck of a lot of difference between moles of solute per liter of solution, especially if you're using water. It's not going to be a heck of a lot of difference between these. However, it is slightly different. It's solvent and not solution. All right, and it's kilograms and not volume. Okay, it's mass, not volume. All right, but like I said, I have spent years when we did not have double periods and we did not have the honors class. I spent years where we did not cover molality. We covered percent solution. We covered molarity. We even covered something called normality, which you're going to get to next chapter. But we kind of let this go. I'm covering this now, though, because I have to use molality to calculate the freezing point and boiling point changes. This is the concept behind why we spray salt on the roads in the wintertime. Why do we put salt in the roads? Well, what does the salt do? You don't know? It lowers the freezing point. Absolutely. All right, that's the whole point. The salt's on the roads so that it will lower the freezing point of water. Water doesn't freeze. If salt water does not freeze at the same temperature as pure water. And that's the whole point of using salt on the roads. It's also, there's a couple of other points we're going to get to when we get to boiling point and freezing point changes. But in order to do that, I'm going to spend this 5 or 10 minutes here just showing you a couple of examples of how to calculate molality, because that's what's used in the calculation, something called molality, not molarity. So, calculate the molality of a solution. If I take, and by the way, you're going to notice these calculations, these examples are almost identical to the examples I did for the molarity ones. They're not very difficult. My guess is you'll understand how to do them just from having done the molarity ones. It is slightly different. You're adding it to the amount of water, not the amount of the total solution. So what you just did back there in the lab, where you added the stuff in first and then filled it up to 30 grams to get a percent solution, okay? You wouldn't do that. You would actually take 2.50 kilograms of water and add it to 40 grams of salt. So there is a slight difference. All right. Let's do this one. I think you all probably would know how to do this. Molality's abbreviation, by the way, is a small m, not a large capital M. Okay? Molality equals moles of solute per kilogram of solvent. Okay, there's no times 100, that's for percent solution. I'm given moles of solute, all right, up here because I'm told I have 40 grams of salt. What will I do? 40.0 grams and convert it to moles. We all know how to do that. Grams on the bottom, moles on the top. 1 mole contains 58.443. Where did I get that 58.443? I added that A and Cl. Just added them up. Bottom is how many kilograms. I've got 2.50 kilograms. What if I gave you grams? What would you do? Would you convert grams to kilograms? Okay, get your calculators out. That's a 5A, it's 58. I know it can't see it very well. Get your calculators out, do the math for that, and we'll be done with this one. We'll do one other one quickly, and then I have some problems for you to practice with. But they're really not very difficult or very different from the molarity ones we saw. What do you get when you divide those out? There. So, what'd you get?
0.274.
Anybody else get that? 0.274? Look right? And that's small m. Small m, not capital M, which means, and by the way, it's actually read molal. Sounds weird. Sounds like some kind of race of aliens. And it really means moles per kilogram. Okay? Moles per kilogram. But those are three different things how I would write it. Small m is obviously the shortest way. The reason I'm putting all those there is so you can see, in the next example, what am I going to do? I'm going to ask you to do something backwards. I'm going to give you the molality. I'm going to say, how much would I need to make it? How much in a solute, how much of the solvent would I need to make that? So there's your second question. We'll do that guy, and we are done. I'll give you guys some problems to copy and start on, which will be due. Yeah. Man.
Are we going to be tested on this?
Oh, absolutely. I mean, I'm just saying, before honors, I didn't always cover this because we didn't have the time. Especially to do the specific lab I want to do on this, freezing point depression. But absolutely, it's on the test.
Are this on Wednesday?
No, I don't think the test will be Wednesday. I think the test will be probably Thursday of next week. Maybe even Friday, but probably Thursday. We'll see. All right, let's go over this guy. Oh, this is another one of those problems, and you don't recognize it right away. That's a strawberries and baskets kind of problem. Doesn't look like it. It doesn't say how many pounds of strawberries did you pick if you picked 2 baskets, each one held 4 pounds. But that's what this is. Because basically 0.865 molal means 0.865 moles per kilogram. Correct? That's what it means. Now, look at the problem. What am I going to do now? Forget about the strawberries and baskets. If you can't understand it conceptually, you can certainly understand it unit-wise in conversions. What else am I giving up here that I can get rid of those kilograms and leave me with moles? I'm giving grams. That's how many grams of water I have. So what is that in kilograms? 0.3. So I'll simply multiply by 0.300 kilograms. Kilograms will cancel. Do the math. See what you get. And by the way, again, if you look back at your examples for molarity, I did one just like this for molarity as well. What'd you get, Jared?
0.260.
Everybody else get that? 0.260? And that is moles. Now, say this question had asked you for, it did not, if it had asked you for how many grams. Well, it would have had to have told you what the solute was, and then you would have done one more conversion, moles at the bottom, grams at the top. But it didn't ask you, so don't do it. All right? I have 4 problems for you to try here on the board. You need you to copy these down on a piece of paper I'm going to give you in a second. All right? Let me these. Those are the 4 problems. Anybody at home who wants to copy them down.